Now we will draw an epicycloid of a circle of diameter 50 mm, which rolls outside a circle of a diameter 180 mm per one revolution. Also draw a tangent and normal to the epicycloid at a point 135 mm from the center of the directing circle. So we are going to draw this epicycloid. First we will draw um, the circle of diameter 50 mm. So, okay, 50 mm. And then after this, it is going to roll on another circle. So its diameter is 180 mm is given. So therefore, I am going to draw one line from here 90 mm. So, 90 mm because 180 radius, 180 diameter, so 90 mm is the radius. Now it is going to roll on this circle. Now I am going to draw that. So on this big circle, this small circle is going to roll. Now what is the inclination that is going to roll? That now we will decide that now it is small diameter, small directing circle diameter is 180 and rolling circle diameter is 50. So 50 by 180 into 360. So it comes out to be 50 by 180 into 360 is 100. So 100 degrees. So we will rotate this line into 100 degrees. So rotate this object. Select this object and enter. Plus base point. Like this. And we require in this way. So my copy and minus 100. Minus 100. Okay. So we are going to roll this circle in this direction. So we'll trim this portion. Next, we will draw a center line now. First, we will divide this the rolling circle into 8 equal parts. Let us say this divide. Select objects, 8 equal parts. 8 input. Okay, it is divided, but the points are not visible, so we will change the point style here. So now we have seen these are the points. Next, we will draw or we will lengthen this. We will draw first the center line. This we will lengthen this line in this direction. And then we will draw a we will give the first names for these points here. Let us say this is 1, 2, 3 like that. So selecting multi-line text, click here, just somewhere. Let us say 1. So try to find. So this is the one. So so I'll copy the same thing, copy, select base point and paste here like this. So now this point name is 2. Double click and edit it. So this point is a P. This point is a P point. So point P. This is 8 point. This 7 up to 8. This point we are considering as a P point, which is on the circumference of this circle. So we can say the same place, the 8, and also it is a P. Note. Next, we will draw center radius arcs from center start end, and this is the center of the directing circle. So let us first give the names. First name of the directing circle. So this is, let us say this is O. It's the center of the directing circle. And here we will place a point also at the center of this circle here, giving its name P naught, center initial stage. So okay. Next, we will draw now center start and arcs. Center start and the center is at directing circle. Center start from, let us say, starting from first we will start draw the center arc. So we will give some other different color here. Now this yellow color, this one is a center line. Next, we will give more number of arcs center start line from 1. We will draw. So hold the control button so that you can change the direction of the arc. Click center start in. Center is O. Then now 2. Hold the control button and draw the arc. Then center start in. From 3 and then similarly from 4. Hold the control button to change the direction of the arc. Next. Now this 5th arc also is going to coincide with this center start end. So from here, from 5th one, so it is also going to coincide with this same. So and similarly, the second one also going to coincide with this 6. So I can just lengthen this in 6. Similarly, this, if I draw arc from 7 point, that is also coincide with the one that which has gone from first. So now we have drawn these arcs. Then I will divide this center line into this center arc into 8 equal parts. Similarly, so divide. So I will select this center line. So 8 equal parts. 8. Enter. Now I will give the names here. So this is Control C, Control V, copy paste. So let us say this is 1, 2, and 3, 4, 5. So this is the center 2. Similarly, this one I'm editing. 2, 4. Then this one is 6. This 7 and this 8. So these are the center 1, initial stage 1, 2, 3. Is a 1, 2. So it is 0, 1, 2, 3, 4 like that. So now we are going to now find out the locus points of the point P that we are going to trace now. For that, we will select first rolling circle. Then we'll move its center from C0 to C1. This is C1. This is C1. Now we will see after shifting from C0 to C1. So center is at C1 and it is intersecting the first line at this point. So I will mark this point now. Okay. This is the point. In other words, this P has come from here to this, from here to here. Next, I will move its center from C1 to C2. So here C2 is there. This is C2. Now it is intersecting the second line here. So I will mark here point. Enter. So this is the point. Then after this, I'll move its center from C2 to C3. Now it is intersecting the third line. This is the third line. The third line. So it is intersecting here. So therefore, point, enter, we'll mark the point here. Next, I'll move its center from C3 to C4. So this is the center, C4. Then it intersecting the fourth line. This one is the fourth line. So both intersected here. So I'll mark the point now. Next, fifth one, I'll change its center from C4 to C5. This is the C5. Now it is intersecting the fifth. This is the fifth line. So it is intersecting the, here it is intersecting. So we'll mark a point here. Then again, shift its center from here to C6. Now it is intersecting the sixth line of this. Next, I'll shift this center to C7. Now it is intersecting here. This is the seventh line, and this is the point, the intersection point. So we'll mark the point here. Now finally, this is the P. This point is a P. So we can shift or we can directly mark there. So if we shift here to here, then we'll find this is the last point P. So our eighth point, this is the eighth line, eighth point. The intersection point is eighth one. So we can mark point here. Now I will just keep the circle back, this rolling circle. Now, once we get all these points, this is the P1. So just to give a name, let us say this is the P1. This point is P1 and this is P2. Let us give here P3. No need to give the names of all the points. Similarly, so this is P4 and this to be here. P5. P6, P7, P8, right? So selection, now we will join them using spline fit here. First option in the draw, spline fit. Select this. Starting from P, join to P1, then P2, this is a P2, then P3, P4, P5, next this is a P6, P7, P8, or this is the final point. That point is coming to this baseline in press center. Now this is the required epicycloid. Now we are increasing thickness. We'll change its color to now. This is the epicycloid. Now let us draw the remaining portion. That is, draw tangent and normal to the epicycloid at a point 135 mm from the center of the directing circle. So this is the center of the directing circle. So 135 mm. So therefore, we will take a circle of radius 135. 135 mm. Okay. So yeah, now this 135 mm circle is 135 mm radius circle is intersecting this epicycloid at this point. So we are going to draw here tangent and normal. So make a point here. Enter is the intersection point. So there we are going to draw the tangent and normal because this point only is 135 mm from the directing circle. And here also one more intersection also there is 135 mm radius circle also intersecting here. Here also we can draw tangent and normal. So, but we are choosing now here at this point. So now we can delete this portion, this circle. So let it be no problem. Now we will draw here tangent and normal. First, we will just copy the same directing circle, copy this rolling circle, just copy this, select this center and paste at this center that intersection point. Or we can say, we can give some name here that we are going to draw tangent and normal at this intersection point. Its point name, let us give point M. So at M, we are going to draw, this is the M point. So at M, we are going to draw tangent and normal. Now just we have copied the same circle, center circle from here to the rolling circle to its center is changed to M. Now we have to see where this circle is intersecting the center line. So this is the center line, this yellow line, this center line. Now it is intersecting here. So we'll mark a point here. PO enter. So it is intersecting here. Now join. Let us give the name here. Let us say some K. Give the name here K. Now join the K point with the O directing circle. So K O. Now it is intersecting the baseline. This is the baseline because this is rolling. This rolling circle is rolling on this directing circle. So therefore, this is a baseline now. It is rolling on this line. So therefore, it is baseline. Now it is intersecting at this point. So this point is N. So we are giving the name here. Intersection point name. It's N. Now join N with M. Join N M. Okay. Now lengthen this NM line. Now this N, give some name at the end point here, N dash. This N dash is nothing but the normal at point M. So we will increase its thickness. Line width I am giving. I am also changing its color to red. Now, if we rotate this red line or normal line at M 90 degrees, we'll get the tangent. So rotate. So base point is M. Copy. U90. Enter. Now this is a tangent. So we will give the name here. Tangent. T dash. T dash. So we have drawn the normal and tangent at 135 mm from the center of the directing circle. From the center of the directing circle. So this is 135 mm. And we will give the diameter also here. So diameter of the circle. So that is 50. And we will give the diameter. So this is directing circle 180 dia. So this is the final figure. Thank you for watching.